Hello, Internet. So today we're going to look at part three of his series. We're sticking with the Blender Guru series on donuts, and we're going to do the exact same thing that he did, except we're going to do it all in Python code. Just some things I thought I'd share about how I do stuff in Python. The surprising thing is that recreating his episodes, Andrew Price's being him, right? In code is surprisingly long. And the reason is that a lot of the things you have to kind of figure out, the information on the internet is just wrong or outdated. Uh, the big one is how you select things. For example, change to now they use KD trees. Before, I guess there was a different selection mechanism. I found it once and forgot it because I couldn't get it to work. It's still somewhere in the API set, but doesn't quite work. Other things are some of these APIs have moved around. I think the duplicate move one or one of the others, I forgot exactly which one. And so when you do a Google search, you find the information for older versions of Blender. And so it's a lot of trial and error on these things. So for about 10 minutes of Andrew's video time is about 10 hours of research and development to figure out how he did it in Python, obviously. So in the video, let's go back to that real fast. In the video, he is, let's see, he's using modifiers, right? He is taking the donut from last time, creating this selection of just the top half of the donut, duplicating it and moving it up around, and then using modifiers to thicken it, right? And that's basically his video for today. So we'll do a code review that shows exactly how you do that in code. So the first thing is let's go up here to the code here. So these are just sort of become my standard imports anytime I'm playing around with Blender, right? PDB is the Python debugger. Math utilities is Blender's variants of various math utils. BMesh is how they define undrawn meshes, and BPY is just basically the Blender Python object, and you use it to grab points or get information or whatever, right? So to make this a little bit easier, the first thing I did is I took out the KD tree and I just made it something that you can make in a simple function. You give it a mesh type and it will return to you a KD tree. A KD tree is a standard binary tree, except that the type of the point or the type of the data in the binary tree is the spatial type, in this case, a point. So, or in this case, a vertex. And each vertex in Blender speak has this .co, which is its coordinate, right? And so that's how it thinks of vertices. So this KD tree is a binary tree. It is by design, by default, binary trees are sorted. I don't know how they do KD tree sorting. I'm guessing they probably create a vector between the point and zero, the origin, and then sort by the length of that vector and maybe some other things like that. But whatever their algorithm is, it's the fastest way to find points similar. The next function I broke out is I created the select vertices, which instead of selecting a single vertex like I did in the last time, it will select as many vertices as you want. Vertices being, let's take a look here at this thing in edit mode. We'll look at the donut. Each of these points here is a vertex. Any one of them is more than one of them is called is called vertices, right? And the statement here is you might want this one and this one and this one, right? I mean, shift click will do it for you in the UI, but how do you pick the ones that you want programmatically? Well, the answer is this function here will do that for you. What it does is it uses the KD tree to find the nearest vertices to a point, and then it gives you a number. Or sorry, this is just selecting, right? So this is, sorry, one more time. This one just selects them. You give it the index of the object. You give it the object, the mesh that you want to select vertices from, and the vertex indices, and it will click them for you, right? And so at the end of this function, you'll get something like this with individual vertices selected. Select nearest set of vertices is how you figure out what the vertices are. So you use the KD tree, you go make one from the item. This is a mesh again. You call the KD trees find underscore n with a vector in space, a point in space, not a vector, right? And the number of vertices that you want. If I want, 20 vertices, then I'll put that in the vertex count here, right? And what it does here is it creates a list, goes through the result set of the find n, and appends that to the list. Find underscore n returns a tuple of lists. The first list is the actual vertex itself as an object. The second list is the index of each vertex that's been found in the mesh. The third list is the distance for that vertex specifically to the point in space. So if you want to find 20 vertices, you're going to have 20 individual vertices found, you're going to have 20 individual indexes found, and you're going to have 20 different uh, distances found, right? And so that's why I always use index 1 because that is the index, which is what my selection function uses. It uses the indices just because they're easier, right, to use than anything else. I took this function that was in the this was in the previous script. I continue to use it, and I was too lazy to change it to this new definition. So I just made a forwarder where I just said, okay, pick one, and that's just a little bit easier to use. All right. I also want to be able to delete anything that's not, sorry, I want to delete anything that is a mesh so I can remake things and not worry about deleting the lights or the cameras or anything else that's normally in the scene. This is a Pythonism that I like to do. It's not a Pythonism, it's a meism, right? I like to add the word pass in Blender Python scripts because of the color coding I get. Like it becomes a nice end function kind of a way to see it when scrolling the list here quickly. So that's all I do it for. Pass is it's essentially a no op in Python. It just means all right, I'm done with whatever I'm doing, right? All right. So then what I did is I took the script from last time and I just put it into a function called make donut. So it's the exact same script as last time, same transforms and everything. It's just called into a function so I can choose when I want to make it and when I don't. It's nice to do it that way just for whatchamacallit. I wonder if it'll run like this. Let's see. Yay, it runs like this. Every time I run the script, it's deleting everything and remaking everything. So the icing, the donut, these items over here, they're new. They just happen to be given the same names and the same transforms. So they look exactly the same, but they're actually unique new items every time. And if I don't want to do that, I can do these. I can just comment them out and run it. But I haven't tested the script to run without actually doing it every time. You can see I got a script failure when I ran it without the delete. Probably because of one of these actions down over here. Doesn't quite work right unless you do it in this order. All right, so I delete all the mesh objects. I make a donut. Here's where I go and make the actual icing. So first I deselect everything. I get the data of the donut. This is still the donut because I haven't made any icing yet, right? This is the mesh. This data is actually the mesh, right? I get the total count of vertices and I add 40 to them. Something I learned is that the way the vertices of this object here work, you would imagine that that half would be exactly what I want, but half is everything but the equator. The 0, 0 vertices are they belong to sort of the top set and the bottom set, so they don't really show up well in that. So I just counted them and said, all right, I need about 40 of them and added that into my math. Simple, easy peasy, lemon squeezy. I then used that nearest set of vertices selection function that I wrote, gave it the mesh, gave it a position. This is 0, 0, 1 would be 1 meter or 3 feet above the donut, right in the center. So it would be right along the z axis, way up, like way up over here. So that's where it would be. And so that basically is going to select the top half. If I move this point, I could select the right half or the bottom half, right? If I made it -1, it would select the bottom half. So that's how I select those vertices, right? Then what I do is I do the duplicate move. This is what Andrew did when he uh, does the duplicate action. I think he does mesh duplicate vertices or something in edit mode. I forget exactly how he does it. You'd have to watch his video again. But that is the code equivalent of it. So I'm literally doing everything the same way that he's doing it. So there it is, the duplicate. And then you can set its position as part of the duplication. So I'd call duplicate move and I say, hey, and when you duplicate it, take the vertices and the object that you have out of those vertices and move them up 5 millimeters. Again, remember the scale is meters, so this is deci, centi, milli. So that's how far up I move. Why did I choose 5? Well, that's because the thickness of the icing is going to be 2.5. So I moved it twice the thickness. Okay, so after that, I call the separate. This is how you go from having one object in edit mode to two objects in edit mode. And I say just take the selected vertices and separate them into their own object. Now my selected objects array is going to have a 0, which is the original object that I had, the donut in this case, and a 1, which is going to be this new object I just created, in this case the icing. So I give it the dot name and I set that to icing, which is how this becomes icing over here. Then I exit edit mode if I'm in it so that I can, you have to apply modifiers in object mode. So I exit edit mode. I just did it manually. And notice that every time I do a command manually in this viewport over here, it shows up right here. So here I'm entering and exiting edit mode. Well, here's the Python that it took to do that. And so I can kind of figure out which functions I need by looking at this Python and just grabbing it over. I also have this Python console. And so if I want to know what something is, right, I can do something like, what is my current edit mode? Well, let's find out. Let's copy and paste that here and just run it. And it says, hey, you're in object mode. So that's a nice hack and trick. Not everything that's in here will be replicated to here, but things like BPY will be, right? And if you don't have the thing that you want, you can just copy it. Like if I wanted to have make donut be available in this REPL, then I would just go and copy, from here to here and run that line by line in the REPL until that function definition became part of that REPL. So that's how I could call my own functions and things like that. Though I find that harder to do than to just use the Python debugger and use pdb underscore set trace to set a breakpoint in code, and then I can interact with that breakpoint from PowerShell, which I find to be a nice way to debug these things as I'm developing them. Anyway, let's continue on. So now I've called it icing. And now I don't know why I did this again. Oh yeah, sorry. You have to be in, whatchamacallit mode, object mode in order to add a modifier. So now I select only the icing. So I use select all with action deselect. That's the same as select none, right? And now nothing is selected. And then I say go search for the icing and set its selection to true. I can run this one by hand. Oops, I forgot to copy it. That's now selected, which is the output of this command here. I then want to get this as a mesh. So I have to call BPY data objects icing to get the icing object as a mesh. So if I can actually run this, then you can see what it is. So now I have icing object. And you can see there it is. And if I do type, how did I get this auto completion? If you hit the dot and then the tab button on your keyboard, it will tell you what what members are available for this thing. So whatever this thing is, the icing object, it has these members on it. And one of those members happens to be one called type right over there. So I can call that type to understand what it is, and that's going to return the word mesh. So I now know that the icing object is of type mesh, which is exactly what I need for some of the functions I'm going to call here. So now the other thing I learned is that the selected object and the active object are two different things. And that one I did not expect. Now that I have two different objects, the selected object was actually the donut. Sorry, the active object is the last object I played with, which was the donut, even though the selected object is the icing. So I need to set the active object to the mesh of the icing object. And I need to do that because the modifiers function works on the active object, not the selected object. The UI will do them at the same time. Like you can see the color, that's the active object as well as the selected object. But Python doesn't necessarily do it the same way. It'll keep the active object the last thing and make this thing the secondary object. You can see I now have two different colors of selection. This is now the active and selected object. This is just a selected object. It's in my array of selected objects, but it is not the active object. So that's what this dark orange color means. So to fix that, I use this. Now the active object and the selected object are the same thing, and I can add a modifier. One of the things about Blender is you can add modifiers over and over and over and over. I don't want to have 100 solidify uh, modifiers added to my icing because that's a bit one too many. Many too many actually. Every time I run the script, and if I turn off the delete all objects first. And so in order to stop that, I always check and then add the modifier. These are what Andrew ended up setting the values to be. He set the offset to 1, right over here, and he set the thickness to 0.0025. So I just copied his values, and there they are. And then he also mentioned moving them around by taking this thing and changing their indices. You can see how the index change happens over here. So I can see exactly what I want to do, and I want to set its index to 0 to make the solidify object come first, and then the subdiv object comes, or modifier comes second. And there you have it. We have completely replicated everything Andrew did in his video in the same way that he did it, except we did it all with Python. Well, I hope you all had fun. Thanks for watching.